Let's solve the absolute value inequality in two different ways. First, we'll use the boundary point method, then we'll use equivalent absolute value equations. Let's solve the absolute value inequality by the boundary point method. First, we'll solve the absolute value equation. The absolute value of 2x minus 3 equals 5. We solve that by making two equations. 2x minus 3 equals 5, or 2x minus 3 equals negative 5. For the first equation, we have 2x equals 8, x equals 4. Or, for the second equation, 2x equals negative 2 when we add 3 to both sides. X equals negative 1 when we divide both sides by 2. Now we're ready for step 2. We have the boundary points x equals 4 and x equals negative 1, and let's place those on a number line. Negative 1, positive 4. Notice our number line now is divided into three different intervals. To the left of negative 1, in between negative 1 and 4, and to the right of 4. Now we're ready to move on to step 3. Let's choose a test point in each of these three different intervals and see whether it makes our original inequality true or false. Let's start with the number to the left of negative 1. Let's say x equals negative 2, and we'll substitute that into our original inequality. Is the absolute value of 2 times negative 2 we put in for x minus 3, is that greater than or equal to 5? Well, let's check. We have the absolute value of 2 times negative 2 is negative 4, minus 3 is negative 7. Is the absolute value of negative 7 greater than or equal to 5? The absolute value of negative 7 is 7. 7 is greater than or equal to 5, so we have a true statement here. Next, let's choose a value in between negative 1 and 4. I like to choose 0. Let's substitute 0 in our original inequality. Is the absolute value of 2 times 0 minus 3 greater than or equal to 5? 2 times 0 is 0, minus 3 gives us negative 3. Is the absolute value of negative 3 greater than or equal to 5? Is 3 greater than or equal to 5? No. 3 is not greater than or equal to 5, so that's a false statement in that interval. Finally, we'll choose a value to the right of 4. Let's let x equal 5. Again, we'll substitute. Is the absolute value of 2 times 5 minus 3 greater than or equal to 5? Is the absolute value of, we have 10 minus 3, so the absolute value of 7 greater than or equal to 5? Sure, that's true. 7 is greater than or equal to 5, so on the third interval, it provides a true statement. Now we're ready for step 4, and we're ready to give our answer. Since the true statements occurred in the interval from negative 1 and to the left, and also in the interval from 4 and to the right, we can write our solution like this. It's the set of all x such that we have x is to the left of negative 1, so we want to say less than or equal to negative 1. Remember, we use the less than or equal to sign because our original inequality had an equal in it. Or, also we have the interval x is greater than or equal to 4. So that's our set builder notation. Now let's graph the answer. Since we have a number line right here, let's put our solution on the number line. We have from negative 1 and to the left of negative 1, and we also have positive 4 and to the right of positive 4. Remember, the solution can be written in interval notation just by looking at the graph. We have the union of two different intervals because an absolute value greater than inequality always results in a union. So we have the interval notation from negative infinity up to and including negative 1, union from 4 to positive infinity. Let's solve the absolute value inequality using equivalent absolute value equations. Notice that we have a greater than or equal to absolute value inequality. When you have a greater than or equal to, you break this into two different inequalities. First, we just drop the absolute value symbols and we write 2x minus 3 is greater than or equal to 5 with no absolute value notice, or we write 2x minus 3 is less than or equal to negative 5. So we reverse the direction and write a negative on the right-hand side. Let's solve both of these. First, we'll add 3 to both sides, and we have 2x is greater than or equal to 8. We divide both sides by 2, and we get x is greater than or equal to 4. Or, let's solve the second inequality. We add 3 to both sides, and we get 2x is less than or equal to negative 2. We divide both sides by 2, and we get x is less than or equal to negative 1. Now we need to put this on a number line. First, we have x is greater than or equal to positive 4, so we draw a bracket with an arrow going to the right. Or we have x is less than or equal to negative 1, so we draw a bracket on negative 1 with an arrow going to the left. The solution is really the union of these two intervals. So, in set builder notation, we write the set of all x such that x is greater than or equal to 4, or x is less than or equal to negative 1. Now notice, for the interval notation, because I have two different intervals on my number line, I need to write both of those intervals in my interval notation. So, moving left to right on the number line, I'll have the interval from negative infinity up to and including negative 1, union the interval from 4, including 4, to positive infinity.